This is lesson 2.3, implicit differentiation. All the derivatives you've done so far this point have been explicit. Y equals this, y equals that. This lesson is going to be when x's and y's are kind of jumbled together, where it's not explicit, y equals. Examples, x squared plus y squared equals 1. X times y plus y squared equals 3. X times y equals 1. None of these are explicit, they're implicit. And there's a way to take the derivative implicitly that we're going to practice right now. So we're going to still take the derivative, but there's going to be a hook-on factor whenever you take the derivative and y is involved. So if you take the derivative with y, you need a hook of y prime, and then there's algebra to get y prime by itself. Here are some warm-up examples. The derivative of y equals x. This is explicit. We've done this. It's y prime equals 1. What's the derivative here? We've done this. Y prime equals 2x. Just a warm-up here. Y prime 2. 2x subtract 1. Subtract 1 to the exponent. And then we need a hook. The derivative of 2x. Subtract 1 is 2. Here. This again is the chain rule. 2 times 1 in front. Subtract 1 to the exponent. I don't need the 1. The derivative of what's inside is f prime at x. Now this is implicit because it's x equals y squared. So the derivative of x is 1, but the derivative of y squared is 2y, but it needs a hook, y prime. That's what we're going to practice today. If you're taking the derivative with y squared involved, you need to have that hook. So y prime by itself, you would divide by 2y, and that would be your answer. All right, turn the page. I want to take the derivative. There it is, implicitly. So if it's x, just what we've done, y, I need a hook after it. So that's negative 6y squared, but I need that hook. The derivative of 3x is 3, and the derivative of 6 is 0. Now, if it has a y prime, it's staying, but if it doesn't, we're going to subtract everything else to the other side. So we have negative 6y squared y prime. I'm going to subtract 2x, I'm going to subtract 3. And then to get y prime by itself, I'm going to divide by negative 6y squared. It is common that when you take the derivative implicitly, x and y will both be in your answer. Find the slope of the lines tangent and normal to this equation. So this is implicit. It doesn't say y equals. So take the derivative. If I'm going to take the derivative here, you need the hook y prime. To get y prime by itself, you would subtract 2x and divide by 8y. I'm going to simplify it for fun. So it's negative x over 4y. And then you plug in the point into here. So I'm going to plug in 3 for x and 2 for y. That will give me negative 3 over 8. Normal, do you remember what the normal would be? So the normal to that would be opposite, so it's positive, and reciprocal. So it's positive 8 over 3. All right, let's practice again. Take the derivative and plug in a point. So that's 3x squared. We have to be so careful here. xy is the product rule. So the first, I'll color code it for you. The first is negative 2x, and the second is just y. So we have negative 2x, and then the second one's y. So what's the product rule? It's the first times the derivative of the second. Well, the derivative of 1y is 1, but it needs a hook on of y prime, plus the second, which is y, times the derivative of the first, which is negative 2, the derivative of y cubed, and it needs a hook on, and the derivative of 5x. Now we're going to get y prime by itself. So do you see what has a y prime in it? We're going to factor out y prime and be left with negative 2x plus 3y squared. We're going to subtract 3x squared. That's negative 2y, so we're going to add 2y, and we already have a 5 there. And then the last step is to divide. So we're going to divide to get y prime by itself. And then this is the derivative, and now I plug in that point. I can do that here. So if I plug in the point 1, 2, So if x is 1 and y is 2, that's what? Negative 3. 5 take away 3 is 2. Plus 2 times 2, that's 6, right? Here, it's 1, so it's negative 2. 2 squared, 3, that's 12. So it's negative 2 plus 12. So that's the same as this. Done. Number 4, we're going to take the derivative of this. Be careful that you include a y prime when you take the derivative with y involved. To get y prime by itself, we're going to subtract 2x and divide by 2y. So that's what it reduces down to. I need to find the second derivative. So I have to do the quotient rule here to do the next derivative. That's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Oops, it's just y. So it's the bottom squared. And then I don't want y prime in my answer. So it's going to be negative y. That's a plus x. And now y prime, we solved that. Y prime is negative x over y, so I can do a substitution. And that's all over y squared. I'm not going to make you simplify it. So there's the second derivative. If you wanted to get common denominators and simplify, you could. But I'm not going to do that. Number 5. Derivative. What's the derivative of cotangent? It's negative. What else? Cosecant squared. And then don't forget the y prime. The derivative of x and the derivative of y. So I'm going to subtract 1 and add cosecant squared y prime here. I'm going to factor. And then the last step here, I'm going to divide. Cosecant squared y minus 1. Okay. I think that's about it. There's actually a trig identity here where cosecant squared minus 1 is negative cotangent squared, and this could actually be negative tangent squared by doing some trig identities. I'm not going to worry about that. That's it. Mr. G Math over and out. Thank you for doing the lesson. Over again. Until next time.